Hey guys, welcome back. We're going to start talking about how to build these ionic compounds now. Like I said last video, there's a reason that they're named a little bit different. And with our molecular, the naming is harder, right? We have to worry about the Greek prefixes and when to use it, when to not. Um, but going in reverse is quite easy. We're going to start with ionics. They're a little bit more challenging, and then I'll give you guys a break with the moleculars because they're a little bit easier. Okay, so building these ionics, a few things are very important: the charge and the amount of each atom or element that we're going to need. Okay, so I have my modified little periodic table. Just try to simplify it so we can find our elements easily. We still have our staircase, metals and nonmetals, and we have our noble gases, so we can talk about wanting to add or lose electrons. Okay, so the first one we want to try is sodium sulfide. I'm going to walk you guys through this. And there's a little bit of a procedure that I like to do. And I think that this little chart or table that we set up is really going to help you guys forward in grade 10 and so on if you guys still need that little support with how to build these. Okay, so first things first, let's try sodium sulfide. Okay, so first thing we need to do is we are worried about what's in it. So we know that there is sodium, and we know that there is sulfur, right? Sulfide is just sulfur. Okay, so there's sodium and there is sulfur. Okay, what I'm going to do is I'm going to break this up into a little bit of a table. Okay, and there's going to be a few things that we're worried about here. So first, we're always worried about the charge, and we're worried about the amount of each element that we need. And then I'm going to put a total down at the bottom. This is going to be the total charge of all of the sodiums put together, or all of the sulfur put together. Okay, so we'll kind of separate it out that way. So first, sodium. What's the charge on sodium? Okay, we'll look back to our periodic table. Okay, sodium, we'll notice is in group 1. It's looking to get rid of one electron to become stable like a noble gas. Right? It's going to loop around just like a game of Worm or something like that, game of Pac-Man, right? You're going to come out the other side. Okay, lose one to become like a noble gas. So its charge is actually +1, right? You get rid of a negative, you get rid of an electron, and you become positive. Okay, we don't know the amount yet. That's what we're trying to figure out. But we could take a look at sulfur. Okay, sulfur's in group 16. It's 2 away from group 18, the noble gases. So in order for this to become stable, we need to gain 2 electrons. Okay, so if we gain 2 electrons, okay, if we gain 2 negatives, okay, if we gain 2 negatives, we're actually going to go back to negative, right? So it'll be -2 will be our charge. Okay, so we have the charges, and now our job is to balance them. Okay, so some of us might be able to think, okay, these aren't balanced, right? That's obvious. +1, -2, not the same. How do we go about making them equal? Okay. First, I'm going to show you guys what we did last time, which is the balance, right? We have Na+1, sulfur -2. How do we get these to balance, right? +1, -2. What we're going to need to do is we need another sodium. Okay. So now we have, in total, we have +2 over here. We have -2 over here. We're balanced. Okay. We can try to think the same way here, right? We need 2 of these. and 1 sulfur, and then to make the total +2, -2. Now we'll notice that we are nicely balanced. Okay? And that's the goal. Our goal is to get these two to balance. So now that they're balanced, we can start to write this out. We know it's going to have sodium. Okay, we always list our metal first. But how many? That's when we take a look at the amount. We need 2 sodium. Okay, how many sulfur? Right, sulfur's next. How many sulfur? We just need 1 sulfur. So we don't actually need to write anything down. We can just assume that there's 1 when we write nothing. Okay, and we know we'll start to get familiar with the fact that all ionic compounds are solids, okay, at room temperature. So sodium, we have 2 of them. Sulfur, we have 1 of them. The challenges are balanced. So there is our compound. Okay, I'll move this down to keep my little periodic table there. Let's try the next one. Magnesium fluoride. Okay, so let's first get our elements, magnesium and fluoride, and we're worried about the same things. We are worried about the charge, we're worried about the amount, and then we want to make sure that the total charges of both match up. So I'll give myself a little grid there. Okay. So magnesium, we can get the charge from the periodic table. Magnesium is in group 2, so it's looking to get rid of 2 electrons to become like the noble gas. So if you get rid of 2 electrons, you're actually going to become +2. Okay. Fluorine. Fluorine is here in group 17. It's looking to gain 1 electron to become like the noble gases. So it's actually going to become -1. Okay, so now we have to figure out how many of each we need in order for the bottom row to be balanced. How do we make the bottom row balanced? We can think about a balance beam, right? We have magnesium with 2 plus, and we have fluorine with only -1. How do we get these two to balance, right? We have +2, -1. We need another fluorine, so now we have +2, -2. Now we're balanced. Okay, those two are going to cancel each other out. Nice and balanced. Okay, so what we're going to need, we can see here, we have 1 magnesium, 2 fluorines. If we have 1 magnesium, we have 1 group of 2, we're still +2. If we have 2 fluorines, here we're -2. Now we're good. Okay, so let's try to build this thing. Switch my color here. So we have magnesium, right? We always list our metal first. How many? Just 1. So we don't need to write a 1. We assume that if there's no number that it's only 1. And then we list our nonmetal, which is fluorine. Okay, and we think how many? We need 2 of them. Okay, and again, our ionic compounds are going to be solid. Okay. Let's step it up a little bit. Let's try a harder one. Beryllium and nitrogen, beryllium nitride. Okay, this isn't difficult because beryllium's hard to say. It's difficult, you'll see, because the numbers aren't as easy as 1s and 2s. Okay, so let's start again with what we need to know. Okay, first things first, beryllium is Be, that's our metal. And nitrogen is our nonmetal. Okay, and we're worried about the same stuff. We are worried about We are worried about the charge, first of all. That's going to dictate everything. We're worried about the amount. And we're worried about the total, which we need to make sure is balanced. Okay. So first things first, the charge. Okay, we can get this off the periodic table. The charge of beryllium, beryllium's in group 2. It's looking to get rid of 2 electrons to become like the noble gases. It becomes positive 2. Nitrogen. Nitrogen is in group 15. Okay, now we're a little farther away. We are 1, 2, 3 away from the noble gases. So it's going to gain 3 electrons. When you're gaining 3 negatives, you actually become more negative. You're actually negative 3. Okay. So now we need to figure out the amount. How many of each are going to be in this compound? Remember, there's only one possible way that these ionic compounds can come together. We need to figure out what that one way is. Okay, and it always comes down to whenever they are balanced in terms of their charge. Whenever we can get these two to balance their charges, that's what the compound is going to be. So we have beryllium 2 plus and 3 minus, nitrogen 3 minus. Okay, so how do we get beryllium and nitrogen to balance? Okay, you guys might think of like the lowest common multiple, right? What's the smallest number that they both get to? We could also think about just going piece by piece. So here we have only 2 positives, but we have 3 minuses. So we need more positives. So we could add 2 beryllium. Okay, so 2 plus 2 plus, now we're at 4 and 3. Okay, now we need more nitrogen. Okay, now we have 6 and 4. We need more beryllium. Okay, now we have 6 and 6. Okay, now we're balanced. Okay, we can also think the lowest common multiple. Maybe you guys see that in math class. Between 2 and 3, right? We go 2, 4, 6, 3, 6. Our lowest common multiple is 6. Okay, so we need to get them. How do we get to 6? 3 times 2 groups of 3 gets us to 6. Or 3 groups of 2 get us to 6. So there's lots of ways to think about this. And I'm going to show you guys a shortcut after this so we can speed this along. So the amount. Okay, we're back to our table trying to figure out the amount so we can write the compound. 3 berylliums, 1, 2, 3 to get to 6 positive in order for these to balance. Nitrogen, we only need 2 to get to 6 in order for these to balance. So our total is 6 positive, 6 negative. That's awesome. That means that we are balanced, right? These are balanced. Cool. So let's try to write this down. Then I'll show you guys the shortcut. So our compound is going to be beryllium, but we need to make sure we have the right amount, right? There's only one way that they can go together. We have 3 beryllium. So Be3. Nitrogen, we need 2. And again, our ionic compounds are going to be solids. Okay. So this is beryllium nitride. There's only one possible way it can come together. We need to figure out what that's going to look like. And our ionic compounds are going to be solids. Okay, so I promised you guys a shortcut. Here it is. Let's see the little bit of a pattern going on. And it has to do with our table. So this is the reason we did the table. So when we take a look at the charge, right, plus 1 and 2, okay, what I want you to notice is that this number, she just slides down over there, and they switch places. Okay, this one goes here, that one goes there. So, and even with the complex one, does this work with the hard one? It absolutely does. Okay, they switch spots. So when we build these tables, sometimes we might not even need to do this. We can just say, okay, if since this one is -3, we must need 3 berylliums. Beryllium is +2. We're going to need 2 nitrogens. Okay, so there's a little bit of a shortcut there, but we're still going to need to know how to balance, right? This is what it's all about. This is how ionic compounds work. If we can understand this, we'll have a really good grasp going into Science 10. Okay, so I'll put up another video on moleculars. I just wanted to show you guys a few, and I'll put a little assignment together. Building, and again, balance, 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 balance. Okay, balance the charges. That's what it's all about. Okay, have fun, guys. Message me on Hangouts if you have any problems, and we can meet up if you like. Cheers.